Hello guys, welcome once more to Class Online, and my name is Dr. Dami. We shall be looking at Waec Physics 2016, question 31 to 35, and we shall be destroying the questions. We shall be making it something that you can do and what anybody can do. And let's get to the question now. Don't forget that if you really learn something from this video, click on like button. We have more content to show you that will better help you understand physics. And let's get to number 31. 31 said the diagram illustrates the waveform of a note produced by vibrations in the air column of length L. If the speed of sound in air is v, derive an expression for the frequency of notes. Now looking at this picture, you can see that this is a fifth harmony picture. This picture has a fifth because it is a closed pipe, so it is a fifth harmonic picture. And you know that generally, if it is a fifth harmonic picture, it will have this formula for length. The length will be 5 lambda over 4. This is the equation for a fifth harmonic vibration like this. Now, if it is a closed pipe and it is fifth harmonic under sound wave, it will have its length as 5 pi over 4. Generally, for the sake of this past question, we know that fifth harmonic wave have the length 5 pi over 4. And where we have to find the pi, because we were told to find the frequency, and therefore we will begin by finding the pi. Now, L equals 5 pi over 4. The reason why it's 5 pi is because it's a fifth harmonic. I said that before. It's a fifth harmonic wave like we have here. It is closed. It is in a closed pipe like this. Whatever wave is in a closed pipe and it forms two rings like this and a half is called a fifth harmonic wave, and its equation is length equals 5 pi over 4. And then to find my pi, I'll make the pi the subject of formula. That will become 5 pi equals 4 times length, right? 5 pi equals 4 times length. Then making the pi, that's removing 5, that will become pi, not pi, lambda. So we have length equals 5 lambda over 4. Then making the lambda, cross multiplying, 5 lambda equals 4 times length, right? Now, removing the 5 from the lambda, I have my lambda or my wavelength as 4 length over 5. And that is my lambda, or you can say that is my wavelength. And that came from the formula for the length for the fifth harmonic sound wave in a closed pipe. Now, having gotten my lambda as 4 length over 5, the next thing to do is to plug it into the equation of wave velocity. Now, the wave velocity equation is very popular. That means one can't really do wave without knowing this equation. V equals F lambda. That is one of the strongest equations I personally have seen in all of wave. V equals F lambda. Now, we are told to find the frequency. So first of all, we will make the frequency the subject. So the frequency is therefore V over lambda. By cross multiplying, by dividing both sides by lambda, I'll be getting my frequency as V over lambda, right? Good. Now, if I haven't gotten my frequency, then I'll plug in my value for lambda into the equation because I was not given my V. So I was told to find my frequency in terms of V. So therefore, I'll put in my value. What's my lambda? My lambda is therefore, from here, I have my lambda as 4 length over 5. So put it in for lambda. That will become V equals 4 length over 5. This means that since there's an over here and there's a division sign under here, the 5 will go up. That will become 5V over 4 length. And that's my answer, 5V over 4 length. And that's my answer for frequency, 5V over 4 length. Now, don't forget the two equations I used. First of all, I knew that V equals F lambda, right? But I knew that for the fifth harmonic wave in a closed pipe, the length is 5 lambda over 4. That's the 5 wavelengths over 4, and that is what I use for solving this kind of drawing. The length is 5 wavelengths over 4, and that is the way you solve it. Now, don't forget that. Now, that will later be explained. We will explain each of these type of sound wave, and in some other video. We will explain each of these kind of sound wave in some other video and clarify them. But this is a past question video, so we just have to pick one of them. You might also want to check them out in your past question, in your textbook. just to see the first harmonic, the second harmonic, the third harmonic, the fourth harmonic, and the fifth harmonic. You therefore see all of the types of the sound wave in a closed pipe and in an open pipe. Now that is a more elaborate way to go about it. Now let's get to the answer. So the answer is therefore 5V over 4 length, and that is my answer for that. Now let's check out number 32 now. It says a pair of musical instruments that work on the vibration of air in pipe is what? Now this is basic 2 question, right? Now which one has to do with air? Is piano and organ, do they have to do with air? Do you blow air when you are dealing with them? No, you don't blow air, you only press. So these are wrong. They don't use air vibration. Guitar and flute, do they use air? Guitar is this way, flute is this way. You have to blow flute, that's air. But guitar is wrong. Guitar doesn't use air. Then that is also wrong. Then we have trumpet and violin. Do they use air? Trumpets use air. Violin does not. It doesn't use air. Then the last one is flute and trumpet. That is the correct answer. Flute use air. They are all wind instruments. They use air. So trumpets use air, and then flute also use air, like you have them here. So therefore the answer is option D, trumpet and flute, because they both use air. So they are called wind instrument, and that settles the number 32. Let's talk about number 33. An astronomical telescope has objective and eyepiece lengths of focal length 3.5 meter and 5 meter respectively. Determine the magnetic power of the telescope when in normal adjustment. Now this is an astronomical telescope, and one thing that we know about is that it has 2 lenses, right? It has 2 lenses. That's 2. One of the lenses is objective lens, and the second one is the eyepiece lens. I drew a diagram of that here. No, okay, I didn't put a diagram. Now, actually, the astronomical telescope uses 2 lenses. One is for your eye, and one is the other one called the objective lens. So now, actually, the power of the telescope is a function of the 2 lenses, and power is the inverse of focal length. So therefore, we have it that the higher the focal length, the lower the power, or the higher the power, the lower the focal length. So therefore, this telescope uses this formula: the objective focus over the eyepiece focal length. The objective focal length over the eyepiece focal length is the magnifying power of the telescope. So that means I will put my F of the objective over the F of the eyepiece. Now my objective focal length is therefore what? My objective focal length is 3.5. and my eyepiece focal length is 5.0 or 5. So then if you divide that, you'll be getting 0.7 as your answer, and that means your magnification power is 0.7, and that is the answer to the question. Now don't forget, for any astronomical telescope, it has 2 focal lengths. 1, the objective, 2 is the eyepiece. You just have to put the objective over the eyepiece, and you are through. And that is how to find the magnifying power of that telescope. Full stop. Now let's check out number 34. An aluminum cable of diameter 4 times 10 power minus 3 meter and resistivity 3 times 10 power minus 8 ohm meter has a resistance of 21 ohm, right? Now calculate the length of a table. Now you have to invert. Now, do you know the relationship between resistance and resistivity? Then length and area. Now this is the relationship here. The relationship between resistance, resistivity, length and area is given by this formula. We learn this formula under electric circuit. That's under electric circuit, when we're learning electric circuit. I mean, resistance is inversely proportional to area, right? Now, and it is directly proportional to resistivity and length. Now you need to you are told in the question to find the length, so make the length the subject of formula. So now I'm going to invert by cross multiplying this formula. That will become resistivity, that's my P, times length equals R times A. Then to find the length, I'll remove the resistivity. Length will now become RA over resistivity, right? That is the master formula to use here. But there's a problem now. The area was not given. We were only given diameter. And you know that the area of a circular substance is pi r squared, right? Now, but also my R is the diameter of the radius. That means the radius, the diameter of the radius, given the radius, then radius is half of the diameter. So therefore, diameter is the mummy of radius, and you were given R. in the question. So it means that you were given the baby. Now how we get the mommy? Divide the mommy by 2. So that means my radius is therefore diameter divided by 2 square, because that represents my radius, because radius is the baby. So but you were not given the radius in fact, you were given diameter. So therefore, I will say diameter divided by 2 squared, right? Now plug it in. So 2 will come on the d, that will become pi d squared. Then 2 on 2, that will give me 4. So the area will now become pi d squared over 4. You put that formula in to this one, you'll be getting pi d squared over 4. Now plug in all the values. So from here, I have my resistance in the question as 21 ohms, right? Then my area as pi diameter square. I got this is my area. My area from here is pi d square over 4. So plug it in here. My pi remain pi. My d square is the diameter given to me is 4 times 10 to the power minus 3. 4 times 10 to the power minus 3 all squared. Then over the 4, right? Then over the formula says resistivity below. So my resistivity in the question is 3 times 10 to the power minus 8, and that's what I have there. Now if you begin to slow that down, the square here comes on the 4. That will become 16. Then 4 cancels 16. This 4 cancels the 16. Now the square outside here come on the 4, and that's 16. The square outside here come on this 10 to the power minus 3. That will become 10 to the power minus 6, because that's 3 times 2, and that will give me 10 to the power minus 6 over 4. Then 4 cancels 16. That's 4. So I will have it this way. So now I am left with my 4. That's 21 times pi is what? Is 263.9. But I've times it 21 times pi times this 4, and that will give me 263.9 times 10 to the power minus 6. Then the 10 to the power minus 8 below will come up. It will become 10 to the power 8, because whenever something comes from down to up, the sign will change. It is negative here, it will become positive here. 10 to the power 8. Then I'm left with my 3 below. So this 3 divide 263.9, and that will give me 87.96. Then the 10 to the power minus 6 times 10 to the power 8, that will give me 10 to the power 2. And that is my answer. Now to bring it into standard form, this point here will jump over to this side, and it will make the 10 to the power minus 2 to become 3. And therefore I'll be getting approximately 8.8 times 10 to the power 3, because of the movement of the point. You see, the point was here, 87.96, but the point had to move to standard form, and that will mean that if it moves this way, this 10 to the power 2 will become 10 to the power 3, because it has moved once, and that will become approximately 8.8, because 9 will be rounded up to 8 and to 1, and that will become 8.8 times 10 to the power 3, because of the point has moved, and that will become 8.8 times 10 to the power 3 meter, and that is the length of the tape. Now take a critical look at this formula. R equals resistivity length over area, and this formula is one of the strongest formulas you can see in the electric circuit. It's very, very important that you master it, because the complexity is just something that you have to spend time with, talking about how diameter was converted to area, and how it was applied to the formula, and how I got my answer. So that is the way you get your answer, 8.8 times 10 to the power 3 meter, and that is it. Now I want you to look up at these workings carefully again and try to trace it. I believe you can get it if you just spend some time to look at it critically, and it will be clear to you. So let's go on from here to number 35. The ammeter A2 shows in the circuit diagram above reads 3 ampere. Determine the reading of the ammeter of A1. Now look at this circuit now. What do you have there? These are parallel. These are parallel connections. You can see 6 ohm, 4 ohm, and you can see 3 ampere here. So you follow for now. What's the relationship between ampere is current now, and this is this 3 ampere applies to the 4 ohm, because it is on the road to the 4 ohm, right? It applies to the 4 ohm, but this 1 ampere we are looking for applies to the 6 ohm. Now what is the relationship between, this question is saying that what is the relationship between current and resistance? Current is in ampere and resistance is in ohm. What is the relationship between current and resistance? Now you must know that is from the Ohm's law. So the Ohm's law says that V equals IR, right? That this current and resistance here, and that means current 1, resistance 1 equals current 2, resistance 2, right? Now we are told to find the A1, that's the second current, because current is in ampere. So now I'm to find I1, and that's my A1. So my I1 is therefore, remove this R, bring it under here. So I have I2 times R2 over 1. Okay, now what is my I2 from the question? My current 2 is 3 ampere, and that's 3. What's my R2 from the question? My second resistance is 4, and that is 4 that I have here. Now over R1, what's my first R? My first R is 6, and that's what I have here, 6. So therefore 3 times 4 is 12 divided by 6, that's 2 ampere. So therefore my R1 is 2 ampere. Don't forget, I created all these things from the Ohm's law because of the relationship between current and resistance. You know, this is all about current. This is 3 amperes current. The 4 ohm and 6 ohm are resistances. You are trying to find the second or the first current. That's A1. So that means it is between current and resistance. And you can only know what is between current and resistance from the Ohm's law. And that is why I use V. This is Ohm's law. This Ohm's law. V equals IR. And my V is I1, R1 equals I2, R2. I just made the I1 the solid, and I got my answer. And that is how to go about it. Now, don't forget that if you learn something from this video, click on like button. We have more content to share with you that will better help you understand physics. Until we see next time, believe it, you are a champion, and you can do it. You can know it. Until we see next time, take care of yourself, and bye for now.